What is assemblies and parts hierarchy in CAD software? Imagine building a complex machine or a detailed product. How do designers keep track of all the tiny pieces and how they fit together? That's where assemblies and parts hierarchy come into play. Think of it as a family tree for your design, organizing everything from the smallest screw to the entire product. When working with CAD software, a part is a single, solid object that represents one component of a larger system. For example, a gear or a bolt modeled in 3 dimensions. When multiple parts are combined to form a bigger structure, that grouping is called an assembly. Assemblies can contain parts or smaller assemblies called subassemblies, creating a layered structure. This setup is similar to how products are made in real life, breaking down a complex design into manageable sections. CAD programs have special tools for creating these parts and assembling them. Part modeling focuses on defining the shape and features of individual components. Assembly modeling involves placing parts and subassemblies in relation to each other. This is done using assembly constraints, which are like virtual joints or mates that control how parts fit and move. These constraints help position parts accurately and allow for movement or fixing them in place. Inside the CAD software, there's usually a tree or browser view that shows this hierarchy. It organizes parts and assemblies into levels, making it easy to see how everything connects. You can reorder or modify parts without changing their actual placement in the model. This flexibility is essential for testing different designs or making improvements. From a mechanical engineering point of view, understanding this hierarchy is key because it reflects how real-world products are built and assembled. For example, a car engine might be broken into subassemblies like the piston and crankshaft. Each of these contains multiple parts, and organizing them this way makes managing the design much simpler. It also helps generate bills of materials, which list all parts needed for manufacturing, and creates detailed assembly drawings. These drawings show how parts fit together and are used in production. To sum up, parts are individual components, assemblies are groups of parts or subassemblies, and the hierarchy is the organized structure that links everything together. Assembly constraints define how parts connect and move relative to each other. CAD tools support creating, managing, and adjusting this hierarchy to match the design goals and manufacturing needs. This system makes complex designs easier to handle, ensures accuracy, and streamlines communication between design, analysis, and manufacturing teams.